The weight of newborn infants is normally distributed with a mean of 7 pounds and a standard deviation of 0.8 pounds. Draw the normal curve representing the weights that are 1, 2, and 3 standard deviations above and below the mean and answer the following questions. Alright, so we'll get to the questions after. So let's just draw the normal curve first, okay? So we'll draw the horizontal here. We'll draw the normal bell-shaped curve. Okay, don't need to be exact here, but it helps to try to draw a nice symmetrical curve here. Right, so this is the mean, right? This is the middle point. This is also the median and the mode. Okay, so we know that the mean is 7 pounds, okay? Now remember, this means that half of all values are below this, which means in this specific example, right, half of newborn infants are, when they're born, are below 7 pounds, and half would be above. Okay, so this curve here is an area, but it also represents the percentage. Okay, now it says that the standard deviation is 0.8 pounds. So what does that mean? Okay, well, if we go up 0.8 units, or in this case 0.8 pounds, so we're obviously going to be at 7.8. And if you subtract 0.8 when we go below, we're going to be at 6.2. But what this means is that if we are one standard deviation away from the mean, right, this represents 68% of all data values. Right, so that means in this example, 68% of all newborns are between 6.2 and 7.8 pounds. Okay, so that's one application that we can use from the standard deviation. Okay, so let's go 2 standard deviations above, right? So we're going to add another 0.8 to this. So 7.8 plus 0.8 is 8.6. And then when we go 0.8 below here, we get 5.4. Right, so if you are between 5.4 pounds and 8.6 pounds, that is 2 standard deviations away. That represents the middle 95%. Okay, and then when we go one more standard deviation, okay, this is going to be 9.4. Right here, we're going to be at 4.6. Okay, so this red markings, right, between 4.6 pounds and 9.4 pounds, that is 99.7% of all data values. So in this case, 99.7% of newborns are between 4.6 and 9.4 pounds. Now remember, the rule of 68, 95, and 99.7, that applies to the middle. Okay, so the middle, the one standard deviation away, is the middle 68%. Okay, so think about what that means, right? Everything from here to here, right, in black, right, this is the middle 68%. Okay? So what if we want to find values below 6.2 or something like that, right? So you have to make sure that you really understand what these percentages mean. Okay? So let's answer these questions, right? What percent of newborns weigh less than 7.8 pounds? Well, here's 7.8 pounds, right? So we want to find everything less than that. Okay. Now, remember, this is the middle 68%, so, and this is also symmetric. So this is 34% right here, and this is 34% right here. But also remember that this is the median. This is the middle point. So half the values are going to be below that. So this is 50% from everything below. So the 50% plus this 34% should give us our answer here, right? So everything less than 7.8 goes all the way, everything, that's going to be 84% of the data values. What about the percent of newborns that are between 5.4 and 7.8 pounds? Okay, this was a little bit trickier, right? Because we don't want to include this part. Okay, but there's a couple of ways we can do this. Okay, now this is the middle 95%, right? So the middle 95% goes from here to here. Okay, and 95 divided by 2 is 47.5. But remember, that 47.5 would be half from the halfway point to here. Okay, so from here, from the 5.4 to 7, right, that should be 47.5% of the values, but there's already 34% here, right, which means that this little region here is 13.5%. Okay, also, this little region right here is also 13.5%. Okay. So then what percent of newborns are between 5.4 and 7.8? Well, in this case, we can add the 68 plus 13.5. That gives us 81.5%. Okay, and what percent of data, or in this case, what percent of newborns weigh more than 8.6 pounds? Okay, So here's 8.6. We want the values that are above it, or the percentage of values that are above it. Now remember, this represents the middle 95%. Okay, so that means that there's 5% remaining, but that has to be split, right? So 5%, okay, divided by 2 is 2.5%. So that means 2.5% are less than 5.4, and 2.5% are greater than 8.6. So then, what percent of newborns are more than 8.6 pounds? Right, that's going to be that 2.5%. Okay, now just a little side note here, right? What percent are greater than 9.4 pounds or less than 4.6 pounds, right? That's 3 standard deviations. The middle for the 3 standard deviations is the middle 99.7%. Let's take a look at that value, right? Well, 100 minus 99.7 is 0.3%. Okay, but remember that's both. Okay, so if you divide that by 2, that's going to be 0.15%. Okay, so if we want to ask that question, right, what percent of newborns are less than 4.6 pounds? Okay, so what percent of newborns are less than 4.6 pounds? That would be 0.15%. But that would also be the same percentage, right? What percent of newborns are more than 9.4 pounds? It's also 0.15%.